All right, so this is on area of composite figures. So our goal for today is I can find the area of a composite figure. Let's talk about the definition. A composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. To find the area of the composite figure, you're going to find the area of the simple shapes and then add or subtract them depending on the situation given. So here is an example. We're going to do 4 examples today with notes, and then 4 examples with day 2 notes, not to overload you on them. But they're all formulas that you already know, so it shouldn't be too much added on. All right, directions are find the area of the shaded region in each diagram. If necessary, round to the nearest tenth. All right, so we'll start with this one right here. Okay, so I want the area of just the blue part, just the shaded part. So I have to make a plan. Okay, so what I like to do first is I like to say I'm making a plan, because the blue part is not a specific shape. But what I do see is that the whole thing is a rectangle. So I'm going to say I'm going to find the area of the rectangle. But if I find the area of the rectangle, that's not the shaded region. What I'm going to have to do is I'm going to have to get rid of the 2 circles. Okay, so I'm going to get rid of the 2 circles. And if you look, the circles are the same. I would put minus circle if they were different. All right, so let's follow through our plan here. I'm going to start with the area of the rectangle. Since they're all A equals, I'm going to put something down right below, like rect right here, to show that I'm finding the area of the rectangle. So area of a rectangle is base times height. So I'm going to do the base times the height. The base is 30 times the height, which is 20. 30 times 20 is 600. And then don't forget your unit, inches squared. That's the area of the rectangle. But now I also need the area of the circles. So I'm going to do area of just one circle. Area of a circle, recall, is pi r squared. So I'm going to do pi times the radius squared. So I need to know what the radius of the circle is. If you look, I gave you the diameter. I just want this piece right here, which is 5 inches. So I'm going to put a 5 right there. 5 squared is 25. So I have 25 pi inches squared. All right, so now I'm going to follow through with my plan. Since I found the rectangle, I found the circle. The area of the shaded region is the rectangle, which is 600, minus 2 of the circles, which are 25 pi. And now I can put this in my calculator. I'm going to round to the nearest tenth. Do the directions say that? It sure does. Round to the nearest tenth here. All right, so I'm going to pull up my calculator. All right, and I'm going to type this in. So I'm going to do 600 minus 2 parentheses 25 pi. Second, and then the up or the caret button will give you the pi. So if you look, that's how it's supposed to be typed. I hit enter. I'm rounding to the nearest tenth. So I have 442.9, and then don't forget your unit. This was inches squared. Not too bad, right? All right, let's try this next one here. So I want to find the area of the shaded region. This time it's made up of 2 figures pushed together. Okay, so I'm going to look at it and I'm going to say, okay, what's my plan? What do I see? So I'm going to write down my plan. All right, so I see first off on the top right here, there's this piece right here, which is not a circle. It's a half of a circle, which is called a semicircle. So I see a semicircle. And what else do I see? I see this down here, which is a trapezoid. Now, could I have said I see a circle, a rectangle, and a triangle? Yes. But the smaller amount of shapes, the least amount of work. Okay. I'm going to start by finding the area of the semicircle. All right, so the area of a circle is pi r squared. This is half of a circle, so it's 1/2 pi r squared. So I'm going to do 1/2 times pi times my radius squared. So I need the radius of this circle. So if you look, I gave you the diameter. That means the radius is 10. All right, now I need to simplify. What just happened there? Undo. Get out of my way. Thank you. Now I'm going to clean this up, okay? So you don't need a calculator for this. What's 10 squared? 100. What's half of 100? 50. So it's 50 pi unit millimeter squared. That's your semicircle. All right, now I'm going to do the area of the trapezoid. Area of a trapezoid is 1/2 base 1 plus base 2 added up times the height. So I'm going to do 1/2, and I need the bases added up times the height. All right, let's see the bases. My bases are 20 and 32. And my height is 14. All right, I'm going to use my calculator for help here. I'm going to do 0.5, parentheses 20 plus 32, close the parentheses, open a new one, times 14, hit enter. That's going to give me the area of the trapezoid, 364 millimeters squared. All right, so now I'm going to follow through with my plan since I found everything I needed. So I'm going to put area equals the semicircle, 50 pi, plus the trapezoid, 364. And now I'm going to put that in my calculator. 50 pi, oops, I accidentally hit alpha. 50 pi plus 364. Hit enter, rounding to the nearest tenth, 521.1 millimeters squared. Okay. All right, let's look at this next one right here. So this next one, I want the area of this shaded region. So I'm going to say, okay, how am I going to get that? What shapes do I see? I see a circle, and I see a hexagon, a six-sided figure. So if I want just the shaded region, what's bigger, the circle or the hexagon? The circle. So my plan is going to be to take the circle and get rid of the hexagon. What's left over? The shaded region. All right, so let's start with the area of the circle. Area of the circle. Area of a circle is pi r squared. So I'm going to do pi times the radius squared. So I look and I say, was I given the radius of the circle? Here's the center. Here's a point on the circle. I was given the radius of the circle. It's 8. So once again, I can do this in my head. 8 squared is 64. And then don't forget your pi. And our unit is inches squared. That's the circle. Now I need the area of the hexagon. Area of the hexagon. Area of a regular hexagon is 1/2 apothem times perimeter. So I'm going to do 1/2 and say, was I given the apothem? No. I was given the radius, remember, so I'm going to leave a space for it. Was I given the perimeter? No. I was given the radius. Okay, so it's going to take a little bit of work to get both of those. So let's start drawing them in, okay? So I like to use the bottom part. As you've seen before, here's the center. I like to draw it in down here. Could I have switched it and used what I already have? Yes, but I'm not going to. I know these two pieces are the same. I know this is the apothem, which I don't have, so I'll start by finding that. Here's the radius. I'm going to draw it in. Do I know the radius? Yes, it's 8. Okay. And then remember, I need this little angle right here. So to get that little angle right there, I'm going to do 360 divided by the number of sides, which is 6, divided by 2. That's 30 degrees. So this angle is 30 degrees. All right, let's solve for A. Here is my angle. This is adjacent. This is hypotenuse. So adjacent and hypotenuse, I'm going to pull up SOHCAHTOA right here and say which uses adjacent and hypotenuse. Cosine. So I'm going to do cosine of 30 degrees is equal to adjacent, which is A, over hypotenuse, which is 8. Cross multiply to solve for A. 1 times A is A. And then I have 8 times cosine of 30 degrees. Remember, don't put it in your calculator yet. You don't need it yet. I'm just plugging that in for apothem. So apothem is 8 times the cosine of 30 degrees. All right, next I need the perimeter. Okay, so do I have the perimeter right now? No, right? But I need the perimeter. So I'm going to come back to my triangle here. And now I need this piece right here, okay? So if you want to draw a whole new triangle, you can. In fact, I suggest it. So I'm going to draw a whole new triangle off to the side. Here's my right angle. Here's x, my unknown. I still know this is 8. And I still know this is 30 degrees. But this time I'm not using the apothem, right? All right, so here's my angle. This time I have opposite and hypotenuse. So I'm going to use sine. So I'm going to do sine. I'm not going to do it right there, though. I'm going to run out of room. I'll do it right here. Sine of 30 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 8. I'm going to move this up just a little bit here. So I can move this up just a little bit here. Okay. I'm going to put this over 1 so I can cross multiply, and I get x equals 8 sine of 30 degrees. Do I plug this in right here? No, that's x. I want the perimeter. So let's get our side length next. To get our side length, we are going to multiply by 2. 8 times 2 is 16, so 16 sine of 30 is the side length. Now I need the perimeter. So how am I going to get the perimeter? I'm going to multiply by the number of sides. The number of sides is 6. So the perimeter is going to be 16 times 6. Let me go back here. 16 times 6. Nope, clear. 16 times 6, which is 96 sine of 30. That's perimeter. So this is P, perimeter. That can go in here. So 96 sine of 30 degrees. All right, it took a lot, but hey, I am close to getting there, I can say. Once again, if you want to draw both triangles separate, you can. If you want to get the apothem using one triangle or the drawing and then draw your other triangle separate, it's up to you. Okay, so now I'm ready to follow through on my plan. My plan to find the area is to do this circle, 64 pi. Minus, and then I have to do minus this whole thing right here. So I'm going to use brackets to write it to make sure. I can use parentheses again, but then it gets a little much. 8 cosine of 30, and then 96 sine of 30. All right, let's type it. All right, first off, I haven't had to do sine or cosine in my calculator yet, and I don't know if it's in degree or radian mode, so I'm going to click mode to see, and it's moved back to radian mode. So I'm going to choose degree. I didn't need it for in degree mode for the other things that I was doing, but if I'm typing cosine and sine, I'm going to need it in degree mode. All right, so 64 pi minus, now the bracket's just a parentheses, so I'm going to do that, 0.5. parentheses, 8 cosine of 30 degrees, close the parentheses, but don't close the third one because we're not closing the bracket yet. Open a new parentheses, 96 sine of 30 degrees, close the parentheses, and then now I can close the last parentheses also. What just happened? And hit enter. It just disappeared. I got scared. And there is my answer. I'm going to round to the nearest tenth. So I have 34.8. And then my unit is inches, so inches squared. Is it a lot for one problem? Yes. But if you go slow through it, it's not too crazy. All right, the very last one here. It's a heart, but I don't have the formula for area of a heart. So I have to break it down into what I see. Okay, so what I see first is I see here's a semicircle and here's a semicircle. But if I have two semicircles that are exactly the same, that's just a circle. So I'm going to say my plan is to find the area of that circle and add to it. I have this shape right here, and I say, what is it? It's quadrilateral, and if you look, I have two sides that are 3, so the other two sides have to be 3 also, so that's a square. So I'm going to do a circle plus a square. I'm going to put a little line right here to separate my work. There we go. All right, so let's start with the area of the circle. Pi times my radius squared. So I need the radius of the circle. At first glance, I might be saying, I don't know the radius, but I do because I know the diameter. Since this is a square, this whole diameter right here is 3 inches, and that means my radius is 1.5 inches. So I can now get my area of my circle. So I don't know what 1.5 is squared off the top of my head, so I'm going to use my calculator to get it. 1.5 squared is 2.25. So if I knew 15 squared was 225, I could figure it out, right? But still, my calculator's there. Why not use it? 2.25 pi, and then don't forget your unit, inches squared. Now I need the area of the square. The area of a square is side times side, or side squared. So all that I have to do is 3 times 3, or 3 squared, and that is 9 inches squared. So now I can follow through with my plan. The area is equal to the area of the circle, 2.25 pi, plus the area of the square, which is 9. So I'm going to do 2.25 pi plus 9, and I get 16.6. Sorry, 16.1, that's not a 6. 16.1 inches squared. All right, that's it for composite figures.